The first thing is when you're finding the equation well, of any straight line in the world, I guess the first thing to do is find what? The gradient. So to find the gradient, well, they gave us 2 points, right? So this line here, right? You can just probably draw a little sketch of what's going on. The line, 1 point on the line, I'll just call it point A, is -3 and 7. That's this guy here. And the other point B is 1 to -5. Now, I'm not drawing this line to scale. It's just to give me an idea of what's going on in the question. And when you're given 2 points, well, you choose 1 point first as usual. You call it x1 and y1. And well, the other point is what? x2 and y2. So those are the 2 points. So remember, I said the first thing we should try to do is find the gradient. The symbol for gradient in the homework was m. And of course, everyone would have seen or remembered this formula by now. So let's calculate the gradient and let's see if everyone is on the right track. So it's y2 minus y1. So it's -5 minus 7 divided by x2, which is 1, and x1 is -3. You notice underneath 2 minus signs end up touching. So on top, we get -12, and underneath we get +4, right? Because 2 minus signs touch to give you a positive. A lot of people got the gradient to be -3. So if you got the gradient to be -3, well, then you are on the right track, right? So for those who did not have -3, at least see where you could have gone wrong so far. So for that straight line, this is what we know so far. We know y is equal to -3x plus what? C, right? So you need to find C now. To find C, you need to choose any 1 point on the line. So you can either choose A or you could choose what? B, right? So find C now, okay? A lot of people are getting different answers for C. So we can choose any point to find C once it's on the line. So I'm just going to choose A. If you choose B, you're going to get the same answer for C, right? It's like magic. So according to point A, right, y is 7. Look at it. We're pretending y is 7. And now we have to pretend the x is -3, right? So we have 7 is equal to, well, -3 multiplied by our next -3 is +9. So when you throw across the +9, you will get -9. So to me, it seems that, well, I'm running out of space here. So I'll move this here. It seems to me C is -2. I'm not too sure how so many people got -13. But if you got -2, you are the ones that are correct. Okay, great. But let me show you what the examiner is asking for in the question now. So normally in maths, if somebody were to ask you, well, what's the equation of that straight line? You would say y is equal to -3x, and we now know C is -2. Now, mathematically, this is correct. And that's how I showed you to find the equation of a straight line in my homework videos, right? However, the examiner just wants a slightly different representation of the straight line. Tell me something, right? Just look up here. If I have the equation x plus 2 is equal to 3. Let's say I have that equation. If I just decide, because this 3 is just annoying me, if I throw across the +3, and we're allowed to throw things across an equal sign in maths, and there's no rule saying we can't do it, the +3 will become -3. And since we are left with nothing on this side, well, we know it's what? 0. Are these two equations the same? Are they considered the same equation in maths? What do you all think? Right? Khadija, correct, right? Khalil, correct. The answer is yes, right? Both equations are considered the same exact equation, right? They are mathematically the same. So all the examiner wants you to do in this particular question, right, is that he doesn't want it in a normal form. For some strange reason, he wants you to throw across everybody on this side, so you have a 0 on this side. And he wants the x's to come first, then the y's, and then everything without a letter. So we throw across the minus 3x, we get positive 3x. Here we have a y, but we know he is positive y. And when you throw across the minus 2, you get positive 2. And now this side is equal to 0. Both equations here are the same exact equations, but he wants it like this for whatever strange reason. And in CXC, you need to read the question properly and put it in the format that he wants. However, if you have a next part of the question to do, like part B, right? To do calculations, any further calculations, sorry, you can just use the orange one, all right? Because the orange one makes it easier to identify who is the gradient and who is the y-intercept. When you put it in this form, the yellow form, it is kind of hard to identify who is the gradient and who is the y-intercept. All right, so for everyone who got it wrong, do you think you spot your mistake, or mistakes, depending on how much you made? So well, we have the original line here, the pink line, and we just found the equation of the pink line, the minus 3x minus 2. I made a mistake, it was be minus 2 there. What the examiner is saying is that you have another line that's perpendicular, that means right angles, to the pink line. And this green perpendicular line is going through a particular point. It's going through the point 4, 6. All right. So I need for you all, for the time being, to find the equation of the green line, the perpendicular line. And then we could try to figure out where the two lines meet. But believe me, you cannot figure out where these two lines meet until we get the equation of the green line, right? And you can just state the equation of the green line the normal way, because for the other line, the examiner didn't tell you to state it in a fancy way. The normal, boring way will suffice. So, right, when you have a line and they are perpendicular, to find the gradient of a perpendicular line, all you have to do is take the gradient of the first line and you find something called, I believe the fancy term is the negative reciprocal, which means, or all it means is that if the gradient of this line is minus 3, to find the gradient of this line, all we have to do is flip this and change the sign. So minus 3 is the same thing as minus 3 divided by 1. So I think I know the answer now. When you flip this, you will get 1/3, but the negative will change to what? Positive. So the gradient of this line is actually positive 1/3, right? So I'm not too sure how so many people got the 1/5, right? But a good few people did get the positive 1/3. Now we have to find what? The value of C. Now to find the value of C for the green line, which point can we choose? Can we choose A, B, and I'll call this one C? Which one is the correct one to find the value of C? It has to be point C, because when you're trying to find the y-intercept, you have to choose a point on that particular line. That point has to be living on the line. A and B not living on the green line. Only point C is directly on the line. So this is X and this is Y. So we're going to throw away Y, replace them with 6. Throw away X and replace them with 4 plus C. So let's try to work this out. 1/3 by 4 is 4 on 3 plus C. We throw across a positive, you're going to get what? A negative, right? Now we're keeping the fractions, right? Because 4 divided by 3 will give us a recurring decimal. I think in a case like that, we should keep it as what? A fraction. So 6 minus 4, you can just use your calculator to do it quickly, which is what I'm doing. 6 minus and use the fractions button. I am getting 4 2/3, or some people might not like the mixed fraction. They'll put it as an improper fraction, which is 14 on 3. So the equation of this green line, right? This green line is y is equal to 1/3 x plus, but I'm going to put the 14 on 3. That looks a little bit neater. All right. Now I'm going to show you a little trick, right? Well, I'll show you on the next slide. Now, what we have to do now, right? Siddiq, something wrong there. You are 42 on 3. Look at my working. It's 14 on 3. Check that back, right? Oh, no. Okay, I understand what you do, Siddiq, right? You're meant to have a space in between the 4 and 2. Sorry about that. I understand what you type now. Right. So, we are trying to figure out where these two lines meet. Anytime you are trying to figure out where two lines meet, what topic is that called in regular boring maths? I'll give you a hint. Starts with the letter S. And I had mentioned that in the homework, because we're trying to figure out where two lines meet. And we have two equations. We have the equation of the pink line, and we have the equation of the green line. And now we're trying to figure out where the two cut each other. Right, Angelo correct, Videsh correct, Emily correct, Kenya wrong, Samir correct, Christian wrong, Wambi correct. Anytime you are trying to figure out where two lines meet or any two equations in the world, it's really simultaneous equations. That is really what simultaneous equations are, you know. You're really trying to figure out where two lines meet. So the two equations we have, and I'm going to set you up with this question. The first equation is y is equal to minus 3x minus 2. And the second equation, the green one, is y is equal to 1/3 x plus 14 on 3. Now, here's the thing, right? Simultaneous equation has two equations, right? So we have two equations. But which one of these equations looks a little difficult to deal with? The pink one or the green one? Which one looking a little like you're squinting at it and you're going, ah, God. The green one, right? That green one, and you know what's making them hard? The fractions. If you had a nice 3 here and just 14 here, well, no problem. You'll be happy to do that question. So here's what we can do. We can alter this green equation to make it look a little bit better. So the problem is you have these denominators. If we get rid of these denominators, well, it will be whole numbers. So in maths, it have this concept where you're allowed to do anything to one side of the equal sign. You do anything in the world, just make sure and do it to the other side. So to get rid of the denominators, look at all the denominators and find the LCM. So the LCM of 3 and 3 is 3. If I decide to multiply this side by 3, I have to do the same thing to everybody on the other side. And you're allowed to do that in maths. And when you do that, it doesn't actually change the mathematical value of the equation. So 3 by y is 3y since you're multiplying by 3 and this 3 is on top and this one is underneath, you'll be left with x or 1x. And of course, this 3 and this 3 will cancel out to give you 14. Now you have two nice looking equations, the pink one and the blue one. Solve these two equations now using any method, but I would suggest using the substitution method. That's the method I am going to use. So everyone get started. Solve the two equations, you will get two answers. One will be the x and one will be the y. Get started. So if you, of course, continue to send your answers, continue, not because I work in it all, you continue to work on your end. So you have two equations, equation 1 and equation 2. So in equation 1, like I said, y is already the subject. So all we have to do now is just substitute that into equation 2. We don't even have to find an equation 3. So when we go to equation 2, we're going to throw away this y, and I'm going to do something wrong. I want you all to tell me what I did wrong. Throw away this y and replace it with what? Minus 3x plus 2. And then I'm going to write back the rest of the equation is equal to x plus 14. Who can tell me what I did wrong there? Justine, correct. I should have replaced that in brackets, because if I'm throwing away this whole y and replacing them with something else, proper procedure in math states that when you throw away something and replace it, you must put it in brackets. So let's multiply this out. 3 by minus 3x is minus 9x plus 6, because 3 by 2 is 6. And we're going to solve for what? Right? You are going to solve for x. So take it from here. You're going to throw all the x on one side, right? Right. So when we throw all the x's on one side, throw across positive x, you get minus x. And positive 6, you get minus 6. So I think I'm getting minus 10x here. And what am I getting here? Did I do something wrong here? 14 minus 6 is how much? Yes, someone, guys. All right, so just for the purposes of the video, I made a mistake here. Equation 1 supposed to have a minus here. So this is really supposed to be minus 6. So when we throw across the minus 6, we'll get positive 6. Right, so now we're on the right track. 14 plus 6 is 20. When you solve for x, you're going to get minus 2. So to solve for y now, we just go to this equation and replace x with minus 2. Minus 3 multiplied by minus 2 is positive 6. 6 minus 2 is 4. It turns out this turned out to be the correct answer. Minus 2 and positive 4, right? Not this one. So I'm not too sure why so many people were sending this answer. All right. But we have the values of what? X and Y. So this is what we know so far, right? We had two lines earlier, right? We had two lines, a pink line, I believe, and we had a green line. So now we know, according to the simultaneous equations, the two lines met at the point minus 2 and positive 4. You have to put the x first and then the y. Now they are saying that if you take this line and connect it to the origin, right? Look, they said it here, origin. And we know the origin is 0, 0. I want you all to find the length of the white line for me. Forget the k and the square root of 5, right? For the time being. I want you to find the length of the white line. Let me put back the formula on how to find the length of a line in case you're a little bit rusty. The length of a line is y2 minus y1 squared plus x2 minus x1 squared. And you have this huge annoying square root sign over it. You have 2 points. Call the first one x1 and y1. Call the green one x2 and y2 and throw it into the formula. And pretend you don't have a calculator and try to work out the value. Right? Pretend you don't have the calculator, and that will make it easier to get out the value of k. Right? Right? For those who want to send a value for k, feel free, right? A little introduction to search, right? If you have two values and you multiply them, look down here. A multiplied by B. Now, this only works for multiply or divider. It does not work for addition and subtraction. So if you have two things being multiplied and you have a huge square root sign over it, so the square root sign it's over both of them at the same time. Did you all know this is the same thing as the square root of A? So you can give the square root of A its own square root sign multiplied by the square root of B. So in other words, if you had the square root of, I'm just saying, 13 multiplied by 7 for whatever strange reason, you could rewrite this in maths as the square root of 13 multiplied by the square root of 7. And it would be the same value. So I hope that helps with this particular question. And of course, you're calling this one x1 and y1, and I ask you to call the next one x2 and y2. Khalil, right? You got one of the answers on the list there, so we'll see if you are correct. Right? Take a minute again. So when we throw this inside here now, we have y2 minus y1. y2 is 4, y1 is 0. Look it down here. So I'll put that in squared plus what? x2, which is minus 2 minus 0 squared. Now, of course, I'll have a big square root sign over the whole thing. So 4 minus 0 is 4. So we end up with 4 squared minus 2 minus 0 is still minus 2 squared. Now, when you square anything in the world, you're going to get a positive value. 4 squared is 16, minus 2 squared is still positive 4. So we're going to end up with the square root of what? 20, because 16 plus 4 is 20. Now, most people cannot square root 20 in their heads, right? So if you don't have a calculator, you have to know that 20 is the same thing as 4 multiplied by 5. I think everyone could agree with that. So what this really means, you could throw away the 20 and replace it with 4 multiplied by 5. And notice you have two things being multiplied now and a square root sign. So this is really the square root of 4 multiplied by the square root of 5. Now, you cannot square root 5, but everyone can at least what? Square root 4. The square root of 4 is 2. And of course, since you don't have a calculator, you leave the other portion as the square root of 5. So that means k is actually 2. That is what they're trying to say here. Well, when you try to simplify it without a calculator to the best of your ability, you're getting the value of k as 2. So for the people who got 2, you all did it right. Okay, so take down the working, right? And that's the end of the first question. That's not right. Right, so here we have another question. You're only doing part A for the time being, right? Now, part A is just like part A of the previous question. So no one is supposed to get it wrong, right? Right. Once again, I don't know the answers, but I'll be putting up the most popular answers and we'll see, who has it right and who has it wrong at the end of the day. So you have 2 points, right? So you have a straight line as usual, right? And you have the first point, point E, minus 5 and 5. Part B, 1 and 7, right? Send your answers if you didn't send it. Even though I'm working it out, you continue to work and send your answers. I'm going to call this point x1, y1. The other point is what? x2 and y2. By now, we know the gradient is y2 minus y1 divided by x2 minus x1. So y2 is 7 minus 5. X2 is 1 minus x1, which is minus 5. So two minus signs touch on the underneath. 7 minus what? 5 is 2. And 1 plus 5 is 6. So yeah, I think the answer is 1/3, because when you simplify, so I'm not too sure why so many people got a half. But the gradient is 1/3. So now that we have the gradient, right? We know, oops, I'm not too sure what happened there. Y is equal to 1/3 x, and we still need to find C. Now, to find C, you just choose one point on the line, right? It doesn't matter if it's A or B. I'm just going to choose A, right? To me, it really doesn't matter. Right? So a lot of people are sending the answer for C, so feel free to send yours as well. So we need to choose one point on the line. I'm choosing point A, but like I mentioned before, if you choose point B, you're going to get the same answer. So Y is how much? Positive 5. That's this guy here. You have 1/3, and then you have minus 5 here plus C. 1/3 by minus 5 is minus 5 on 3. The minus 5 will just go on top. Throw across the minus, you're going to get what? A positive. So 5 plus 5 on 3, I think this will give you 6 2/3. Because number 5 on 3 is the same thing as 1 2/3. So when you add it, you just get 6 2/3 or 20 on 3. So that to me seems to be the normal way to write. So if we write the equation the normal way, we'll get y is equal to 1/3 x plus 20 on 3. But the examiner doesn't want us to write the equation in the normal way. He wants it in this funny looking way here. So we need to get rid of the 3's underneath. So we multiply out throughout by 3. And we'll get 3y. 3 and the 3 will cancel out here, leaving it with x or 1x, however you want to write it. 3 and the 3 will cancel out here with 20. Then he wants you to throw everybody on the same side, but he wants the x's to come first. So I think if we do this, we will get minus x plus 3y minus 20 is equal to 0. Isn't it supposed to be minus x, guys? Some of y'all put in minus 3y. Check it back. The x is the one with the minus sign. For those who got it wrong, you seen the mistake. The x is the one with the minus sign. Some people put it, you see, a lot of people are not accustomed to seeing a minus sign come first. But in this particular one, it's right. No, well, okay, I understand what some people do. They instead of throwing everybody across on this side, they just throw across this on the other side. So let me put that into perspective. Where can I write here? Some space on top here. Right. So what some people do, they are allowed to do this, right? Instead of throwing across the x and the 20 on this side, they decided to throw across the 3y on that side. So the 0 will be on this side now. And then you'll get x minus 3y plus 20. This will also be correct in the exam, right? The examiner won't take any harassment. All right, so to find midpoint, the formula says, not wait here, midpoint. What you need to do is add the 2x coordinates and divide by 2. And then we add the 2y coordinates and divide by 2. So we have, well, the 2, this time we added it. So for this one, it will be minus 5 plus 1, and we divide by 2. That's the 2x coordinates. I'll put little dots over there. And then for the y coordinates, I'll put little ticks over there. 5 plus 7 divided by 2. I don't think we'll get any. I'm not too sure why. I don't think we'll get any of these answers. Minus 5 plus 1, that is minus 4. Minus 4 divided by 2 is minus 2. 5 plus 7 is 12. 12 divided, that's 6. Is minus 2 and 6. How come so many people got this? And rare people got this. But the answer is, so to me, the midpoint, I don't think I make any mistakes there. The midpoint, I'll put the letter M, is minus 2 and 6. Right? What they are saying is that the midpoint, which is minus 2, 6 now, is connected to the origin. And we know the origin is 0, 0. You're trying your best to prove that the blue line and the yellow line are perpendicular to each other. Whenever you're trying to prove two lines are perpendicular, you need to find the gradients of both lines first. We know the gradient of the blue line, which is 1/3. Quickly find the gradient of the yellow line, and then I will show you all how to prove using gradients that the two lines are actually perpendicular. Right? But send the gradient for the yellow line first. That's your first task. All right, so for the yellow line, we can just call one point x1 and y1, and the other point at the end x2 and y2. So it's y2 minus y1, 6 minus 0, and then minus 2 minus 0. I get it 6 divided by minus 2, which is minus 3. So the gradient of the yellow line is minus 3. So these two lines are in fact what? Perpendicular. Because remember how, if two lines are really perpendicular, if you look at the blue gradient, which is 1/3, if we flip this, we get 3 on 1. And if we change the signs, we see that we get back the minus 3. Remember, you saw that in the videos. If you have two gradients next to each other, if you could flip one and change the signs, you actually are getting the gradient of the other line, which means that they are perpendicular. In other words, each one is the negative reciprocal of the other. Right? So they are perpendicular. All right, so the next one is actually just a quadratic simultaneous equation. This was from the over the holidays, but it is always get a question like this in the CXA exam. All right, so I want everyone just to begin with this question, see how much you can remember from over the holidays, right? It's two equations. The first thing you do is what? Label it equation 1, you label it equation 2, and when you substitute one into the other, you're going, instead of getting a nice equation, you're going to get a quadratic equation. All right, so get started. I'll give you a 2 minutes head start. You have two equations. So you have equation 1, right? And you have an equation 2. Equation 1 and equation 2. Well, which one of these equations is the scarier looking one? Well, which one doesn't look too normal here? 1, right? So you're going to have to change up equation 1, I would suggest, so that it looks a little bit better, right? So you have 3 on x minus 2y plus 4 is equal to what? 0. The problem with equation 1, which I just wrote, is that you have this annoying x underneath. I mean, if the x was on top, well, it would have looked pretty normal. So we need to get rid of that x. So what we can do is employ the procedure. Whatever you do to one side, do anything in the world, just make sure and do it to the other side. So if I decide to multiply everyone on this side by x, the top I mean, you're allowed to do that, just make sure and do it to the other side. So I have to multiply the 0 by x. Now, by doing that, you will notice that the x and the x will cancel out here, just leaving you with 3 minus 2 multiplied by yx is 2xy or 2yx. The order doesn't matter. You have 4x here, and 0 by anything is 0. All right? So now you have a proper looking equation 1. So I would consider this to be my equation 1 now, right? I actually don't care about this guy anymore. And look at equation 2. It's so easy to make y the subject. And to make y the subject, you just have to throw across what? The minus 7 to get positive 7 and the positive 4x to get minus 4x. So this is a really easy equation 3. Go to this equation now, and wherever you see the letter y, throw him away, and in brackets, replace it with 7 minus 4x. And when you simplify that, you will get a quadratic. So you have 3 minus 2x, and look at how the letter y here, right? Open brackets, and inside the brackets, we could put what? Isaiah, what does that even mean? You had homework to do. Is that you do the homework or you didn't do the homework? I'm not too sure what that sentence means. But stay, Isaiah, you will stay back after class with your parents too. Make sure your parents in your room, please. Right? So what we're going to do is multiply all the brackets here. Minus 2x multiplied by 7 is minus 14x. Minus 2x multiplied by minus 4x is minus 8x squared. Plus 4x is equal to 0. Now, I suspect a lot of people would have forgotten the squared over here because they're multiplying an x by a next x. So you realize it's a quadratic here. So to solve the quadratic, you have the 8x squared. I like my x squared to come first. Minus 14x plus 4x is minus 10x. And then you have the annoying positive 3 there. So this is the value of A, this is the value of B, and this is the value of C. Throw it into the quadratic equation, right? Right? Solve the quadratic. All right. So 10 plus 2 is 8. 8 divided by 16 is a half. 10 minus 2 is 8. Sorry. 10 plus 2. Sorry. Oh, I should have said it. 10 plus 2 is 12. 12 divided by 16 is 0.75, better known as 3/4, and the next answer is a half. Right? So well, when you work out this piece underneath here, minus 100, sorry, minus 10 squared is 100. 4 by 8 by 3 is 96. So you end up with 100 minus 96, which is 4. The square root of 4 is 2. Right? So what did we just solve for? Did we just solve for x or did we just solve for y? Well, which one did we just solve for? X, correct. Because our equations only had x in it, the quadratic had x. So the two values for x are 3/4 and a half. But if we get two values for x, we're supposed to get two values for y. So go back to equation 3 and replace x with 3/4, work this out, and you'll get your first corresponding value for y. Then replace it with how much? A half. And work it out again, and that will give you the corresponding y value.